Anybody who has been awake for the last year or so has probably noticed that we're kind of approaching a bit of an event horizon for software development. Time is kind of compressed and changed. We're getting weird laws of physics changing and kind of new particles appearing that we've not seen before. People are making hundreds of thousands of lines of code. You don't even have to take my word for it. You can look at some of these famous people who have kind of come across on the journey who've noticed this change. So this is Hnry. He's like an AI engineer, did a whole bunch of the self-driving stuff for Tesla. John Carmack, talking about how these tools will change game development and change, open up new things that people can do. Even Kent Beck is looking at that and saying, things have shifted around, right? What we could rely on before, these Newtonian physics have suddenly got all Einsteinian and spooky action at a distance. And because of the Ruby meetup, we have to talk about DHH even. Love him or loathe him, he is, kind of saying it might actually be underhyped, which I think is possibly. But, buckle up is certainly the right message there, right? So this is 134 days, and this is how long our startup has existed, right? So it's not a new rom-com. Unfortunately, I wanted to just take you through what we've learned in the last little while, what we've seen about these new laws of physics, and how you can use them all to your advantage. You've probably figured out who I am by now, but in case you haven't, my name's Nik. And I make Sterling, that's why it's all over me, basically, at all times. And it is an AI agent assistant accountant. I'll take you through some of what Sterling does a bit later, but unless you're doing finance stuff, which hopefully no one here is, you won't have too much use for it. But if you know and like your finance people and they look a bit stressed come month-end time, get them to give me a ring and we'll sort it out for them. I'm going to talk about two things today. How we take advantage of these new laws of physics to become better software engineers, and how we can use the changes that we've got now to be better for our users. So yeah, you can fly now, basically. This is the output of Rails stats on Sterling, on our main app. There are 3 of us in theory. Ellery joined us. Welcome, Ellery. Ellery joined us early Jan. We started on October 16th. And Ludwig is, he says he's not a software engineer. He's a designer, but a decent amount of that code is him. So in a little over 4 months, we have generated 180,529 lines of code. So that's quite a lot. And even, 80% of that in test as well. That's 1,347 lines of production code that's running in production, solidly delivering tasks for our users. And that's every day, including Christmas, right? So we did actually generate some code on Christmas. Work-life balance is not a thing when you're a founder. I run 4, actually this is a little bit out of date because I am completely broken and I now run 6 of these at all times because I kept running out. But I run 4 to 6, Ludwig runs 6 to 8 Claudes at all times, basically on Tmux as well. So you run them on Tmux and then you can sign in on your phone with the Termius app and you can keep going whenever you want, right? And basically it becomes a matter of having 4 to 8 agents doing what you want at all times instead of just however fast you can type. And I don't know how fast people can type, but they can still go faster. How do you manage that? You've got heaps of them. You've got to figure out how you're going to split up your tasks and split up your work amongst them. It's not a world anymore where you can kind of just take one Jira ticket and sit on it for 3 months, right? You're going to have to kind of take a few different things. What I tend to do is I give them names, or I figure out what the jobs I want them to do are. You don't have to give them names and personalities, and you probably don't want to get too attached because occasionally it's cathartic to just press Control-C a couple of times if it's not giving you what you want. But what I generally do is I'll have 1 or 2 for whatever big feature I'm working on at the moment, and we'll be churning backwards and forwards on that. Then I'll have a couple for like little random questions or small fixes and things that come up. And I'll keep one kind of free at all times in case there's something urgent, some kind of production issue or something like that. So, and how that split turns up depends on how I'm feeling in that particular day or whether I'm doing deep work or whatever. Sometimes if I'm going through a feature, I'll chunk it out into 3 or 4 things and give it to 3 or 4 agents. And you can remember that the code is free, right? You don't have to worry about their feelings. Claude Code doesn't have any feelings. And that means that you can ask it to go off and do a feature. It can churn away for a few hours and then come back to you, and you can take a look at it and go, actually, now I look at it, I don't like that, throw it away, right? And if you did that with a human that you were managing, you wouldn't get to do that too many times before they were quite frustrated with you, right? Because they've gone and put in a whole bunch of effort. But in this case, it's just generated, it doesn't matter. Code is free. You really have to learn how to get multi-threaded, right? You can't do one thing at a time anymore. Like I said, you can't sit on a Jira ticket. This looks like me doing like a whole bunch of different jobs here, but that's just so I feel better. It's basically me doing the same job 4 times, which is yelling at different Claudes. But this makes me feel more productive. It is a new way of working in terms of the effort to code ratio, right? And how you can structure your time and in fact, your life. Again, hopefully most people have a much better work-life balance than me, unless you're also founders, in which case you probably have the same level of work-life balance as me. So what you can do is you can kind of say, hey, I'm going to go walk the dog, right? Don't ask me any interactive questions because I'm going to be out for, 40 minutes. Collect everything into a questions markdown file and we'll review them when I get back. And yep, 1 out of 10 times it will have gone off on a tangent that you don't like, and you can just kind of press Control-C and start again. But the other 9 out of 10 times you'll get a really tight focused list of questions. It will have made good decisions and you can kind of go, yep. Those kinds of things are really good tricks for getting a long churn, right? And we'll talk a lot about like keeping the loop going and getting a long churn. That's what you want. You want as much as possible that kind of thing. And it means that I can generate, that 180,000 lines of code that we can push out. We can generate that with a much lower amount of mental effort, right? Because all I've got to do is do the high level orchestration and decide where we're going to put things. I don't necessarily have to go through every single line, right? It's a force multiplier. A lot of people use Ralph loops. Who has heard of a Ralph loop? Yeah, okay, sweet. So this is a revision for some of you, but for everyone who hasn't heard of a Ralph loop, it's named after Ralph Wiggum by a very funny Australian guy. Is it Huntley? Jeffrey Hunt? I don't know. Anyway, the idea behind a Ralph loop is that you just keep telling the model to keep churning, and you have a defined good outcome at the end that it can slowly iterate towards. It's kind of the LLM interpretation of the whole 1% better every day thing, right? You're just churning it again, you're using the loop again and again and again and again, and by keeping that long context going, you iterate closer and closer and closer to your end goal. All that requires from you is to have a really crisp idea of the end goal and to put structures in place such that that end goal is very easy for your LLM to evaluate, right? This is how you need to think now, right? You're not writing the code, you're not an artisan with a plane anymore, kind of working on one cabinet for 4 weeks and then pushing it out. You're building a factory, right? And that means you need something that works at pace and something that allows you to operate at speed and still have the same level of quality that you'll have if you're manually inspecting the tomatoes one by one, right? That means you're thinking about what are your quality gates, how do we automate them, how do we get that nice loop so that we get the long context and the 1% better. We have hard and fast checks, right? And you will notice this is pretty much exactly what you have now, right? Which is 57 checks on every CI that are yes or no, right? You either get a tick or a cross or we're working on it for GitHub. I'm sorry, Nick, it is GitHub. And it's the same things you're doing now, right? But you're just turning them up to 11. So a good example for us is you can see in there we have a design system lint, right? One of the problems that folks have with LLM generated code is, especially for design, it's not visualizing what it's putting through, so it will come up with a new type of button every time, and designers aren't fans of that, as we're all probably aware. So we talked with Ludwig, who is our designer, and we said, okay, well, how do we make something that will work for an LLM, right? How do we change the way we're actually developing the software so that what we get out of the LLM is better? How do we put in the little thing that kicks the buttons out, right? So that we don't even see those, right? And so what we have is we went to a component-based system very, very early. We created a design system like 3 weeks into the project, right? Which you wouldn't do normally. You'd go, why do we have a design system now, right? But that means we can lint it. We can go through and say, do we have any Tailwind styles that are not in our design system, yes or no? And if it's no, we send it back to old Ralph and we say, Ralph, go again. Easy as that. We have evals that test our, wait, did I skip one there? Oh, it's okay. We have evals that test our model layers. This is how you know you haven't broken anything, especially when it comes to any LLM-based features or LLM-based functionality. This also works for anything where you're not using the tick or the cross anymore. You've got a 0 to 100. It's great for performance testing, SLOs, these kinds of things, right? So we run a whole bunch of these, and actually we do have a lot more since I took this slide. I think I put in 42 today. And what an eval is it's effectively this is our spreadsheet formatting eval. Turns out accountants really like spreadsheets. Really like spreadsheets. However much you think they like them a whole lot more. So basically we have an expected output, we have kind of a golden, this is what it should look like on the end, and then we have an actual output. This is generated by calling a live LLM. We spend a little over $100 a day on OpenAI tokens, almost entirely just for our development, right? And this is running these evals and doing these kinds of things. And you score that. So you go through and you do a cell-by-cell diff of the actual cell content, the formulas, the metadata, and you basically come up with a scoring system where you say, okay, I'm going to get a 0 to 100 out of this. And this is exactly the same, or really similar to your kind of traditional yes-no error test cases that you have. Build kite folks will know all about, except it's obviously you've got it on a continuous scale. So you can set the agent at it and you can say, hey, this gets 78 out of 100. I want you to keep going until it gets 85 and just go for a walk. A lot of people talk about code quality with LLMs, and it has been a meme. It's a meme that's largely gone away with the release of Opus 4.6 and some of these latest frontier models. But we don't let the model just generate, right? Again, we've got the little paddles that are kicking the green tomatoes out before we even see them at the end of the pipeline. So we have approximately 84 checks that come through, and these are code quality checks. And we've built them up over time from our PR reviews, right? So if I get a PR review sent up by Hnry and I say something, when he merges it, he uses a special / command that will go and look at the PR comments I've put in and decide whether one of those is a rule that we should be adding to our quality. So is it like this is a general principle that we should be applying, or is this only specific to this case? And it'll keep adding them. So it's basically taking our revealed preferences of PR reviews, because it's what we're actually doing, and encoding them into a markdown document, right? And the good thing about this is you can have things like skinny controller fat models, right? And that is that's an interpretability problem, right? That's how skinny is skinny, right? But you can give those things to an LLM, and an LLM can make a determination based on that, right? Based on your description of that, and so we have the big long markdown file with a paragraph on what that means. One of the problems we did run into is with agent adherence, right? So you give it a big long list. Agents are inherently lazy, like LLMs are inherently lazy. I think it's because Sam Altman's billions run out eventually, and so they don't want to run the inference bill. But what they'll do is they'll kind of get 20 checks through and they'll go, oh yeah, sweet, seems good enough, I'll just pass it through. So what you do is you rely on the fact that LLMs are really susceptible to the don't think about an elephant problem, in that if you put anything in the context window for your LLM call, the likelihood that it gets spit out goes up, right, by exponentially. So even if you say, whatever you do, do not output anything related to an elephant, you will start to get big ears in Africa and pachyderms out your output, right? Because it's a stochastic, like that's the whole job of an LLM, right? It's a next token predictor, so you're relying on that. So what we do is we say on GitHub, you need to put a PR review that runs through all 84 of those checks and says yes, no, not applicable to them. And that requires it to go and think through each one. So like again, this is how we're using this to build that factory that lets us go at pace, right? You want to avoid the slop cannon effect, right? And if anybody is kind of saying to you something like, hey, we can't review all the PRs that are coming through from the AI, right? They're coming through at too high a rate. You need to dig into what they're saying. And what they're really saying is the PRs that are coming through are requiring too much review. The quality is not high enough on those. And that means we need to go back and sit and say, okay, well, what are our gates? What are the gates that would push these and that would mean the reviewer doesn't have to spend time reviewing slop out of the slop cannon? A lot of people talk extensively about code quality. Code quality is kind of a contraindicator, right? If people are worried about that, they're not operating at the level of abstraction that you need them to operate at. So when you write Ruby code, are you looking at the machine code that Yav is generating out of them? Are you kind of going and saying, no, it unrolled that loop and that's not effective here, right? You're not. Presumably, I don't know. Is somebody like an insane person who's doing that? I don't know. Come talk to me after because that sounds like really good fun. But you're not diving into those layers of abstraction, right? You're trusting the layer of abstraction below you. Otherwise, we'd all be coding with a needle and a hard drive platter, right? And so that means you just need to worry about what are the outputs? Do my evals pass? Do my tests pass? Are my users happy? Rather than the inputs, which is your code. Another common objection is folks will start to say, well, I'd love to move that fast, but you have a brand new greenfield system and we've got a creaky legacy system and we can't operate on our creaky legacy system like that, right? And I guess what I'd say to that is, well, we have 180,000 lines of code now, and so we just got a legacy just a whole lot faster than you. And also, the things that humans are bad at, AI is bad at faster, right? So the same things that cause it to be difficult for humans to operate, poor documentation, poor factoring, missing domain models, that kind of thing, that'll make an AI bad at operating it as well. The thing is, humans will suck as well, but they'll suck really, really slowly, right? And so that's your decision. Do we want to suck slowly or do we want to suck fast? Or do we want to get out of the suck faster? That's how we power ourselves. Like that's how we use these tools to most effect to make ourselves faster, better software engineers. But what about the people who are using the software that we've built? So in our case, what about these folks in the finance teams who are incredibly, incredibly put upon, and that's why we exist, right? One of the most important things that you need to realize in this new world, in these new laws of physics, is that agents now exist, right? Not just LLMs, agents. Nobody wakes up, right? And they would say, I'd like to today, this morning, right? I'm going to go to my job and I'm going to run a multi-trillion parameter frontier stochastic prediction model, right? They don't do that. They've got a job and they need an agent to go and do something for them, right? And this is an important change in how we've built software, right? Software up until now has been about presenting us with choices, giving us buttons or things like that, right? Your software now needs to do things for people, for your user. What do I mean by agent? A lot of people kind of get tripped up on the definition of agent. They say, we've got an agent, and really you've got a chatbot that runs the UI. Chat is not always a great way to run a UI. It's a bit mystery meat. An agent is something that operates and calls tools in a loop, right? So it goes and does things. It responds to signals from the outside world, and it keeps going, right? So that's the difference between an LLM and an agent. Agent can do stuff and keep going. Again, you've got to trust this loop, right? This loop is your parachute. You are trying to get that agent looping as much as possible, and you are trying to keep it going until it gets to your defined end state. So you need to know very clearly what is our defined end state, and you have a deterministic place where you can get there, and then you just keep pushing the agent until it gets there. And we'll talk about a couple of ways to do that. This is Sterling filing an invoice. Don't worry, you don't need to read all of that. The important thing is look at how many different things it's doing, right? And this is what we're doing the whole way through Sterling. Every time it creates an invoice, it actually then needs to call the API into the GL and go, did I actually create the invoice and does it match what we were intending, right? And this is a way that everybody's seen that error rate graph, right? The 1% error rate that goes up and up and up and up and up as you go through turns. This is how you get rid of that, right? Because every single time you're kind of coming back down as you go. Does that make sense? GL, sorry, it's a general ledger. that's the finance team equivalent of the GitHub repo, basically. Yeah, it's like the most important central of everything. Clarifications are really important. We talked about that kind of gold standard when you're doing an eval. We talked about that kind of grounding the goal for your end loop. One way you can get the grounding as you're going through is you can ask the user, right? So you can say, should this thing be counted as GST or not GST? If you're not sure, you can go and ask the user, get 100%, and then you continue on based on that. It's a really important pattern is to be able to ask the user for clarifications. The folks who are using coding agents, which is hopefully 100% of people, you will have seen it come up with clarifications for you already. One of the great things you can do now in this world of agents is that you don't have to encode every possibility or everything that the user might want to do into the application, right? Your application can actually be a lot broader, all right? So we can kind of say, do a standard invoice AP process. And by the way, if the invoice mentions an elephant, make sure you email Jerry and let him know that the animal's escaped again, right? So we can have that, and that only works for the one zoo customer that we have, right? This is super, super powerful because this is the age of infinitely customizable software. We've all had those tickets that constantly move to the bottom of the backlog because there's 4 people in Outer Mongolia who actually want it. Now they can do it for themselves, right? This is power for our users. An important way to get this for folks is to make sure that you're getting the right things to your agent, again, so you can keep that loop going. So when you're returning things back to your agent from tool calls, don't just say validation error. You're not giving it enough information to get things right. Instead, you kind of say, hey, the description must include an animal and 3 to 5 proper nouns. And you'll be really surprised how good an agent is at self-healing at that point, right? Because now it's getting an error message. It'll just go and try again. It'll just keep ralphing itself up against a brick wall if you let it. And you'll get to that kind of 1% better, 1% better, 1% better. Basically, every time during the process of this where we've gone, why is this stupid model not doing, why is it not calling this tool? Why is it not doing that thing? It's turned out to be the fact that I didn't give it that tool, right? So we had a bug, or I accidentally didn't give it the invoice tool. So now it's trying to reconstitute an invoice from a CSV file and doing curl commands to try and get something going, right? They're really dogged. They'll keep trying. There's more about this. I'll add the links, as Jordan said, to Slack. There's more about this back pressure idea in much better detail and depth on this blog post. You can have wider loops as well around your existing loops. So what we do is we give Sterling itself, so we give the agent a way to tell us if it would have been more efficient. So it'll do the invoice task for the user, for our finance team, and then it'll come back to us and say, hey, by the way, I would have been much faster at creating that invoice if I'd had a tool where I could split PDFs in half. Cool, okay, you can have a split PDF tool. We have not yet hooked it straight back into Claude Code, but you will notice this copy for LLM button. Those proliferate across our operations panel, and I can't recommend anything more highly. So we basically copy for LLM, paste it in there, come back in a half a day, and it's got a new feature. Also give it the ability to alert us in Slack if something weird's going on. It can kind of say, hey, here's the thing. It can even talk to us. Often Ludwig will be confused about something that's deeply technical, and he will kind of tell the agent to go and interview me in Slack. So we'll start sending a Slack message, and then I talk backwards and forwards to his agent, right? It's kind of really cool. You can easily overload these things, right? As smart as they are, they still suffer from a focus problem. Everyone will have probably heard of the haystack problem, where agents are poor at pulling a specific piece of context out of a large part of context. You give it the content of Moby Dick, even though it technically fits in the context window. If you insert Nik and Ellery had coffee at 6s and 7s in the middle of that, give it that whole whack of stuff and say, where did Nik and Ellery have coffee? It will have no idea. Right? It's really poor at whittling down context. And actually what we found is that 400K context window, or whatever you've got, is kind of gives you a bit of a false sense of security. You'll find that your performance will drop off a cliff probably well before then. especially if you give it disparate jobs, right? If you kind of have one specific goal, it's like go create an invoice, you'll be fine. But if you say go create an invoice and then like while you're at it, go and check the other accounts to make sure that they're right. And while you're at it, do a bit of fraud checking, you'll quickly find that the performance drops off. So what we do for that, those kind of like while you're at it jobs, is we do sub-agent orchestration. So we have one main agent that runs everything, and that kicks off a whole bunch of sub-agents. This is really good for a couple of reasons. Like one, that performance reason that I talked about, because if they have specific tasks, they can do better. It's good on your bottom line because each turn of the sub-agents, because it's a smaller agent doing a smaller task, fewer tokens, Sam Altman takes less of your money, very nice. And it's also faster, right? Because the turns are smaller, so therefore inference is faster. What we did find is that for the sub-agents, you need to treat them really carefully, right? Initially, we just said, hey, this is a sub-agent tool, and the orchestrator agent thinks, okay, it's a stupid tool, it's some stupid code. I'm just going to ask it for everything from A1 to Z1000, and then I'm going to work it out myself, right? And what we found is that then they were passing things back in the context, blowing out the context window, and everything was going wrong. So what I did is I took the orchestrator agent aside and the sub-agent aside, and talked to the sub-agent, talked to the spreadsheet sub-agent. I gave a bit of a pep talk, right? You're a very smart agent. You know how to do things. I want you to be clever. People make $1 million decisions based on what you're doing. You know, you're a smart tool. I also gave it the ability to give back pressure back to the orchestrator, right? Hey, you've asked for too much here. You shouldn't be asking for this much. And then the orchestrator, I said, make sure you give the sub-agent context. Give it the information it needs to do the job or the tools it needs to go and collect that. And our eval performance went through the roof, right? So it's kind of funny how that works, right? Like, turns out all these things you've learned to be a good manager of humans are also applicable to agent management. I'll go really quickly because there's pizzas here and I don't want to keep people from the pizzas for too long. But code is free, so you can have all of the analytics and charts and everything that you want, generate them for free. Code is free, so if you have something fun you want to do, you can just go and do it, right? You probably don't have to ask for permission because you can just wait till you have a spare Claude. In this case, we send you approval reminders if you need to approve an invoice. And I thought, hey, it'd be fun if they were customized depending on what kind of invoice it is and what the weather is where you are. So you get this approval reminder with a cute image and you are the third fastest approver this week, that kind of stuff. And you can just do it because code is free. We have this important principle of marshmallowiness, right? Basically, you have magic technology. You have an LLM that understands language, and so use it where you can, right? So a lot of the times you'll be building a finite state machine or something. You'll be saying if A, then B, then C, right? You'll be kind of building these big case statements or something, and you go, hang on a second, I have an LLM. I can just throw everything into that, and out of my magic bubble is going to come exactly the process that the user wants in this time. Because you will find that the real world does not conform to a finite state machine, and you'll just lose whatever hair you have left trying to make that work, right? The real world is much more marshmallow than it is anything else. But you also want a steel skeleton. Like, it's really important that you have these things in here because there are some things that are invariants, right? Either you can or you cannot charge GST. And the IRD is somewhat of an invariant on that, right? If you have an approval process, somebody needs to approve it, they need to sign in with their SSO and like maybe with their passkey as well, right? You need to actually know who that person is. And you don't want the LLM kind of going like, it's only a small invoice, it's fine if I skip it this time, right? We have a new employee mode, like a planning mode. Basically where Sterling will come to you and say, hey boss, I'm going to do A, B, then C, then D. Is that all right? And you say yes, right? And before you give it the yes, it can't change anything. It's not allowed to send an email to anyone. It's not allowed to create any invoices. It's not allowed to do any approvals, right? And we don't do that by saying, important, critical, we will kidnap your family if you do this. We don't do it that way. We do it by not giving it the tools. That is a steel skeleton. Right? The agent cannot satisfy its way into doing anything that writes because we only give it read tools. It's the same with approvals. The agent itself cannot move an invoice from draft to approved. It has to call the approval tool, which means it has to go through the steel skeleton. So, yeah, now you kind of understand some of these different laws of physics. You heard kind of what we've done in the last 134 days, what we've learned in how we built a year's code in 4 months. What you need to be thinking on Monday is kind of why would you opt in for a 50% handicap, right? I'd urge you to kind of stop thinking about what's going away, what's different, and start thinking about what you can do with the new laws of physics now. And that's me. I think everybody can have pizza now. Oh yeah, hit me.
You mentioned at some point, like, spending, was it $100 a day?
Yeah.
Do you have like an estimate of like, in this 134 days, like how much you spent on like tokens versus, you might not have this figure in your head, like, I'm just asking for a rough thing.
Yeah.
Like the cost in tokens versus like having like a larger development team. Like, I imagine that might be like a cost benefit analysis you would.
How much does the developer cost?
I don't know.
I'll answer that for you. A lot more than $100 a day, and I'm getting 6 of them. So yeah, and the thing with the larger development team as well is that like you get more orchestration issues that creep in as you add more people, right? The administration of doing that is a lot higher. Like once you get 5 people, now you need a manager of people, and so some amount of their time is now taken up by, and rightly so, taken up by making sure that everybody's happy and getting development. And once you've got 8 to 10 people, now you start to need a bigger office, and you need a bigger office that's going to accommodate your growth, because when Hnry signs a lease on this office here, they want to change it around, and it's probably a minimum 24-month lease, right? And they need to be able to grow into that. You've got 60 people, there's a lot of things whereas my tokens I pay a small extra bill every day. Yeah. But yeah, I hazard a guess that you cost an order of magnitude more than $100 of tokens a day. Yeah, go ahead.
Early on, you said something about having a clear idea about what you wanted it to do.
Yeah.
What do you do when you don't?
So you explore, right? The same way you would if you were rubber ducking with someone else. Like it's not like we only talk to the agents. Like I'll call Ludwig up and I say, like, I have this idea, what do you think? And we'll kind of go backwards and forwards. And then we'll each go and like kind of talk to our agents about it. The good thing is that they're infinitely patient, right? So you can kind of go backwards and forwards on a stupid idea for 8 hours, and it'll quite happily be like, yeah, that's good, that's bad, that's not. And it helps you it's a sparring partner in the same way like a rubber duck is, and it'll help you kind of come back with something. I often say to it like, go look up 6 papers on this. When I was implementing the memory system, I was like, okay, go look up papers on this and like 57 things that somebody's written on a blog post about it, and maybe look at the 2 best software offerings for this, and let's come back with a list of like the top 5 things that they all have in common.
And from that you get a clear idea about what you want to do?
Yeah, because I can then take that information and apply it to our problem and kind of go, okay, well, these are the things that we actually care about, and these are the things we don't, right? So for like, I have extra context in my head. For instance, like we are less context length sensitive than a lot of folks, because we're doing much more high value operations, right? We're taking away hours and hours of expensive people's work versus like maybe a chatbot use case or something like that. You've got a lot of people going through that, or medical note taking, you've got 30 patients a day going through that. So they're very token sensitive, but we're not. So when I'm implementing the memory system, I can go and say, well, memory decay is kind of important for the performance reasons I talked about, but not as important as these folks who do a medical note taking system. So it's kind of it's exactly the same processes. I guess if you're taking one thing away, like none of the things you're doing have really changed from what you're doing now. There's just more of them, and they're faster and cheaper.
I was wondering if you just kind of ran more kind of agents, because I've got a lot of dumb ideas, mostly with
So
of stupidity coming at me.
yeah, and definitely I've gone and said, like, go implement this, and then gone and looked at it and gone, oh no, that's wrong. But actually, now I look at the code, I realize what's wrong about it, and I couldn't sort of put my finger on it before. And sometimes you just have to like see the code to go, ugh, like, no, that's awful. And yeah, often if you can't describe it, it's a sign that you're not going to, if you can't even describe it to start with, it's a sign that you're not going to have a good end state, right? Like it needs more thinking. But yeah.
Are there any tips you would have for someone wanting to try this way of development as a side project, so whether having to spend their own money?
Aside from like go get a new job where they pay for as many tokens as you can eat, I don't know. I mean, so we use the 20x. So the $100 a day, by the way, is for us running our evals or running our production agent, right? So that's for OpenAI. We also pay Anthropic for Claude Code, and we all have do you have the 20x plan now? Yeah, so we all have the 20x, which is at 350 New Zealand dollars a month. So it's not cheap, but as far as like a professional certification go, to be a chartered accountant costs you $1,200 a year. So like $300 a month is not, on a professional developer salary, it's not backbreaking, I guess, especially if it's something you're getting better at. But yeah, I would question why your work wouldn't want you to.
Some people might work at places where if you do side projects at work.
That's fair enough, right? Yeah. But yeah, you can get a long way, token switching across the different models as well. You can go like a $20 plan on 3 of them, and you can just, I have a /second opinion skill where I make my Claude go and ask Gemini and Codex what they think. So you could do the kind of a similar thing, right? When we run out of credits on Claude, we just go to AMP, which uses 4.6 underneath. It has a slightly different agent harness. So, yeah. Anything else?
You mentioned that you generate 1,000 lines of code per day on average. Are you still reading the code? And the next question, I guess, is are you even writing any code at all, or were you just telling, if you see something that's weird, you tell the agent to edit it?
Yep, fix it. Yeah, not writing any code by hand. Not at all. Not a single one of those lines was written by hand. Some of them with 4.5, not 4.6, because we didn't have it until, December? No, was it? Yeah, December. So it was, most of it's 4.5. And then I even think there's some Sonnet before that, but yeah. Are we reading all the code? We're like reading the vibes. It's like, you get the PR and you look at the PR and you can pretty quickly tell, the agent really got it and understands everything in there. Like we could still, if you ask me like a whiteboard test, like what are the components of the application? Like I could draw, here's the inbound comm system and the outbound comm system. And, we did a bunch of refactorings with the tool objects where we started with them all being in the database and we moved them out to POROs because we wanted to be able to test them more easily and they were much more static. And so I'm giving it architecture things where I'm saying I want these to be POROs and I want them to follow that. We're also engineering such that it makes it easy for models to follow. So things like having a directory of POROs for all of your tools, because you know that you're going to add 57 ones of those, models are really good at, like that, but in blue, right? And so if you do that, it makes it a lot easier. And often if you're looking at stuff, you'll see a case statement, it's like case this with 57 cases. You and I would look at that and would probably put a comment on, maybe we should use some metaprogramming or something like that. But actually for an agent, you just let it cook, right? Because best example is we were down in Nelson for a team catch up, right? And I was arguing with Ludwig about what we should call, whether we should call our main thing a task execution or a run. And he's like, task execution is clearer. And I said, well, run is shorter and it's easier to type. And he goes, you're not going to type it. So that's how you got to think.
You bring it at a higher abstraction level, not really.
Yeah.
Yeah, just about models and
Yep.
rather than the individual lines of code.
Yep. You're not going through and going, unroll that loop, don't unroll that loop. Move it into that register. No, that needs to go into the heap. You're not, right?
And you're thinking about naming things so that helping you can understand it better rather than
Correct.
run you might call task execution. So.
Yep. Yeah, so that it knows the difference between that and that concept, because they're like semantically distinct, right? Like the more you can move them away. I mean, LLMs don't work this way, but the more you can move the concepts away from another. Like LLMs use superposition in all the nodes, so like the same node will encode for like Bushido, the Great Fire of London, and the Golden Gate Bridge, right? And that'll all be collapsed in the same hyperparameter set. But I find, rightly or wrongly, that if you can keep the concepts semantically distinct, the LLM is less likely to confuse them. So, but yeah, the thing is, the more you're having to do stuff like, I think the LLM will be better at this, the more you're losing. Like, it needs to be, you need to have that little thing that's going like, this tomato is too green, and this tomato is like not green enough, like that kind of, yeah.
Do you like make it write the test first? Do you do test-driven development, or do you just not care? You don't care?
Nah, TDD doesn't matter for models. Like okay, that's a pretty bold statement. I find that asking it to do TDD does not improve performance in the same way that it does for a human. I personally only do TDD if I'm like implementing a particular algorithm or something like that. But usually if I'm implementing an algorithm, I'm like got a paper, right? And the paper's got like pseudocode or some LaTeX thing that I'm implementing. And so that's an outcome. So I would just pass that to the model and say, go towards this outcome. And then the tests are really it just like backfilling the don't think of an elephant to the outcome. Does that make sense? Yeah. So like the reason you would do the outcome is to make it easier for you as you're iterating towards it. But it's already got the outcome there, and it's not as stupid as you, so it doesn't forget them. I mean, stupid as me, not as royal you. You know what I mean? Like, we're really bad at remembering like a long random string of stuff. Humans suck at that, but models are really good at that. So. Cool. If you want anything else, maybe just come up and ask me, sir, because I don't want to keep people from pizza. Yeah.